Assalamualaikum. Today our group will present about gravitational and Kepler's law for PH5 533. Okay, I will introduce my team members. First is Muhammad HAZIQ IQBAL bin MUTALIB. Second is NURHIDAYATUL NABILA binti Muhammad SANUSI. Third is me, AINA FATEHAH binti N. Fourth is SITI NAJIHAH binti RAZAK. And the last one is NASHA ALIEZA binti ABDUL HAMID. Okay, this is the list for the gravitational and centrifugal force. First, 1.0 Introduction. Newton's law of universal gravitation. Every particle is attracted to every other particle with a force that is directly proportional to the product or the masses of the two particles and inversely proportional to their square distance from one another. Our formula for the gravitational is Fy equals to G mi mj over r squared y. Okay, Newton developed this gravitation law while studying in the moon. He wonders why the moon does not drop to the ground like an apple. Then he understood that the moon was being accelerated centripetally toward the Earth due to centripetal force. The moon would not strike the Earth if it were to break away from its orbit due to its high tangential velocity. As a result, the moon would travel far sideways from the Earth if the detachment were an apple experienced the same thing. If a cannon fired an apple with sufficient energy, the apple will orbit the Earth and never touch the ground. Just like the moon, if there was no air resistance, it is because the pace at which the apple falls away from the Earth's surface is the same as the rate at which the Earth's surface falls away from the apple. According to Newton, the moon also orbits the Earth in this way. This describes how the particles pull together. The attraction force between the two masses will vary with distance and is said to be inversely proportional to the square of their distance from one another. The distance between the Earth and the Moon, both of which have masses m and whose centers are respectively, is how the law of universal gravitation is derived. Assume that the Earth is divided into circular rings of equal breadth. As shown in figure 5.11, the circumference of each ring and its mass are as follows. A minor component of the Earth ring acting in the Moon's direction relative to particle A exerts gravitational pull of the Moon. Force can be divided into two parts. The first one is along the magnitude line between the Moon and particle A. The other factor is the magnitude of the separation between the Moon and the Earth centers. The Moon's perpendicular vector sum would completely disappear. On the other hand, the force acting in the direction between the Moon and the center of the Earth can be reduced by adding the component of the formula is as follows.
Assalamualaikum. I will continue this presentation. It's about Kepler's laws of planetary motion. The first law of Kepler's law is law of ellipse. It defined as all planets are orbiting in ellipse with the sun located at one of its foci. So an ellipse is a closed plane curve that resembles a stretched out curve. Note that the sun is not at the center of the ellipse, but at one of its foci. The other focal point, F2, has no physical significance for the orbit. The center of an ellipse is the midpoint of the line segment joining its focal point. A circle is a special case of an ellipse where both focal points coincide. As you can see, based from figure 1, an ellipse is a closed curve such that the sum of the distance from a point on the curve to the two foci, F1 and F2, is a constant. A circle is a special case of an ellipse in which the two foci. So as we can see in figure 1 is law of ellipse. Figure 2 state that for any closed gravitational orbit, M follows an elliptical path with M at one focus. Kepler's first law states this fact for planets orbiting the Sun. Law of equal areas. It defined as a connecting line between the planet and the Sun sweeps out equal areas in equal times as the planet orbits the Sun. See below. For an instruction of this effect, the planet traverses the distance between A and B, C and D, and E and F in equal times. When the planet is close to the Sun, it has a larger velocity, making the base of the triangle larger, but the height of the triangle smaller than when the planet is far from the Sun. Okay, one can see that the planet will travel fastest at perihelion and slowest at aphelion. So that is figure 3, which is Kepler's second law. They state that the shaded region has equal areas. It takes equal times for M to go from A to B, from C to D, and from E to F. The mass M moves fastest when it is closer to M. Kepler's second law was originally devised for planets orbiting the Sun, but it has broader validity. Law of harmony. It is defined that the square of period of a planet is directly proportional to the cube of the semi-major axis of the planet's orbit. The third law, published by Kepler in 1619, captured the relationship between the distance of the planets from the Sun and their orbital periods. Symbolically, the law can be expressed as square of P directly proportional to cube of A, where P is the orbital period of the planet and A is the semi-major axis of the orbit.
My name is Muhammad IQBAL bin Talib. I will explain about gravitational and Kepler's law in our daily life. So, gravitational force, also known as gravity, is the force of attraction that pulls two objects together. Every matter with mass has a considerable gravitational influence on its underground things. So, gravity, in a simple term, is the natural force that pulls a body towards the center of the Earth or any other physical object. Gravity is heavily influenced by the mass of the object and the distance between them. Okay, so as we can see, I've already prepared three examples of the gravitational and central force as example, and I prepare one example for Kepler's law in our daily life. So the first one is fruit falling from the trees. So when the fruit is on the tree become fully ripe, they naturally fall to the ground. Surprisingly, it is a mechanism that is responsible for the discovery of gravity. So, Sir Isaac Newton was inspired with this concept of gravity after observing an apple fall from a tree. He then pondered the question of whether the moon would fall if the fruit of the tree fell. So, the story of Sir Isaac Newton and the apple tree is well known in the scientific world. Okay, next slide. In this slide, I will explain about Kepler's law in our daily life. Okay, Kepler's law in our daily life is applicable for any satellite. This law apply to both natural satellite and such as the moon. and the man-made satellite. As we can see in the picture, there is a man-made satellite. Okay, a satellite can be sent into space in either an elliptical or nearly circular orbit, depending on its mission. The motion of a central follows Kepler's law of planetary motion and is independent on its origin, whether natural or man-made.
Assalamualaikum, I'm ALIEZA binti HAMID. Today I will talk about problem and solution about Kepler's law. Next slide. Okay, the question is a particle in a central field move in the spiral orbit R equal to c theta square. A. Determine the force function. B. Determine how the angle varies with time. Next slide. The solution is we know the formula R equal to 1 over U. So from the question, we substitute into the question U equal to 1 over C theta square. Then we differentiate first time du over d square. Then we differentiate again. We got 6 over C theta negative 4. Then we got 6cu square. From the equation d square u over d theta square plus u, we substitute into it. Then we got negative 1 over ml square u square f u negative 1. F u negative 1 is equal to negative ml square 6cu 4 plus u3. So we substitute R to get the R function, negative ml square 6c over R4 plus 1 over R power of 3. That's the answer. Next slide. B. Determine how the angle varies with time. We know the formula L equal to R power of 2 theta dot equal to Lu square over L 1 over C power of 2 theta power of 4. Theta power of 4, we differentiate, we got theta power of 4 d theta equal to 1 over C square d theta. We integrate the equation, we got theta power of 5 over 5 equal to Lc with 2 power of negative 2t. Then we want to know how the angle, the angle is constant, we just equal to 0, theta equal to 0 at t equal to 0. Then we got the answer.
Assalamualaikum, my name is SITI NAJIHAH, and to conclude for the topic of the gravitational and Kepler's law, according to the Kepler's first law, the planet's path is an ellipse with the sun at one focus. As per Kepler's second law, if a line is drawn with a certain radius from the sun to a planet, the area that line will sweep out over time will remain constant. Thus, according to Kepler's third law, the square of the orbital period corresponds to the cube of the radius. This is true not only for planets orbiting the sun, but also for satellites orbiting the Earth. From Kepler's law, Newton's universal law of gravitational can be derived. So now is question and answer time. If anyone have any question, you can ask now. Okay, Putri Nur Akila.
I want to ask, how does gravity relates to Kepler's law?
I would like to answer your question. How does gravity relates to Kepler's law? The planets move in elliptical orbits with the sun at one focus. This is one of the Kepler's law. This elliptical shape of the orbit is a result of the universe square force of gravity.
Any other question? Nur Azira?
I want to ask about Kepler's law. Actually, what is Kepler's law used for?
Okay, I will answer this question. As we know, the Kepler's laws describe the orbits of planets around the sun or stars around a galaxy in classical mechanics. They have been used to predict the orbits of many objects such as asteroids and comets, and were pivotal in the discovery of dark matter in the Milky Way.
Alright, thank you.
Maybe we can have a last one question.
I would like to ask, does Newton and Kepler is different?
I would like to answer this. In my opinion, the main difference between Kepler's and Newton's law is that Kepler's law describes the planetary motion around the sun, where Newton's law describes the motion of the subject or object and its relationship with the force that is acting on it. So, is that answer your question, Ain?
Yes, thank you.
Okay, I think that's all from us. Thank you very much for joining us and give your time for us to do this assignment. Thank you. Bye.